many options. In fact, there's another networking talk happening right now. The good thing is all sessions are recorded, so you can always watch recording at the end of the day, I believe. My name is Charlie Wen. Jared and I are program manager on Azure networking team. We have a lot to share with you. We'll talk about new capabilities. We'll share the lessons we learned from customer support cases. We'll do some demos. And we also have a guest speaker from Johns Hopkins University, and he will share with us their story and their experience of using ExpressRoute. Now, to start off, I want to give you a quick overview of ExpressRoute. First and foremost, it's a network service. It sets up a private connection between you and Microsoft. So on this private connection, you can access to many Microsoft cloud services. We categorize these services into two groups. The first one is IaaS, or essentially it's Azure VNet. So for Azure VNet, you define and use a private IP address. And this VNet connects to your on-premise private network. And for this reason, we call it Azure Private Peering. So this is this blue arrow here. The second one is this red line. We run Azure PaaS and SaaS services on Microsoft global routing table. There are only public IPs there. And for this reason, we call it Microsoft peering. Now, because this is a private connection, it bypasses the internet. It bypasses your ISP, your ISP's ISP. So it gives you a more predictable performance. Now, one thing unique about ExpressRoute is when you set up ExpressRoute circuit, we actually set up two connections. We call the primary connection, secondary connection. We guarantee that these two connections are created on two physically separated routers. This allows us to give you the availability SLA even for a single customer for a single circuit. Our competitors are not offering this for one connection. Now, you can connect to Microsoft, you can connect to us in many locations. We also added some locations recently. These are the green dots. We have more coming up. We select these locations based on customer demand and also based on availability of Azure region. So every time you hear us announce a new region, rest assured we'll set up ExpressRoute location next to this Azure region. You may also see two trends from this map. We are setting up a second POP in some cities, like Washington, D.C., London. We already have a second POP. We already have a second location in Amsterdam, in Singapore. So we give you a choice. You can set up a redundant connection from the same metro. Another trend is we are also expanding to locations and countries where we don't have Azure regions, like Taipei, like Kuala Lumpur in Malaysia, and Auckland. So this is actually Azure. What you are seeing is Azure Commercial Cloud or public Azure. We also have 3 instances of Azure. In US, we have a cloud for our US government, for DoD, for federal, for local, state, and local agencies. In Germany, we have a cloud for Germany. And in China, we have one for China. We also have 2 new locations coming up in China. Now, one common question we got is, my business, my office, my private data centers are not in any of the locations on your map. How do you connect to us? So that's why we are developing a very strong and growing partnership ecosystem. Now, remember, like 4 years ago, we only had 4 partners. Today, we have 200 plus. Our success really depends on our partners' success, because Microsoft doesn't operate on last mile. So for any customer, they need to work with the service provider to connect to us. If your service provider is not on the list, you can find the list on azure.com. Let us know. We'd love to solve your problem. So this is really a 10,000-foot view of ExpressRoute. Now, before we dive into some new features, new shiny features, I want to share with you the lessons we learned. I have a list of do's and don'ts. Let's go over them one by one. The first one is if you still have Azure Public Peering, do you plan to migrate to Microsoft Peering? So we announced the merging of Azure Public Peering and Microsoft Peering last year. I think in April, we also disabled the API to create Azure Public Peering on your new circuits. There are many benefits to use Microsoft Peering. For example, you can create a route filter. You can basically define what IPs you want to receive from Microsoft. You can also use your own NAT. Because once you own your own NAT IPs, you can basically, for example, you can set this echo on your Azure SQL instance. When you set up Microsoft Peering, use public ESN. The reason is we recommend you to have 2 ExpressRoute circuits, and many of you want to influence routing by playing some BGP attributes. For us, because we are mentioned, it's a Microsoft global network, we are not on a private ESN. So if you want to influence routing, you need to use a public ESN. You need to send us public ESN. So that's our recommendation for you. So we recommend more than one ExpressRoute in different locations because many things are out of our control, out of your control. If there's a natural disaster, one ExpressRoute location goes down, you don't want to lose connectivity to Microsoft. Now, I mentioned each ExpressRoute circuit has 2 connections. So do set up BGP sessions or do establish connectivity on both your primary connection and on your secondary connection. Because we do maintenance from time to time. Sometimes it's a planned maintenance, sometimes it's unplanned maintenance. For example, if we need to patch a security hole. So we don't want you lose connectivity again when we do this maintenance. Now, we also know many of you set up a firewall for your Microsoft Peering. That's the right thing to do. However, when you set up a filtering, use URL filtering rather than IP filtering. Because a lot of the time, our services, our PaaS services, or our SaaS services change IP dynamically. Because when we do the service maintenance, when we're expanding, we change IPs. So you specify URL so you will not lose connectivity to these services. So these are the do's. We also have things we don't want you to do. The first thing is, now when you set up ExpressRoute, particularly for the private peering, you set up a virtual network. You set up a virtual gateway. You may want to define UDR for your gateway subnet. When you apply UDR to your gateway subnet, do not specify the default route. The reason being, our gateway is a managed gateway. If you specify this default route, connectivity will be broken between our gateway, between your ExpressRoute gateway and our management plane. So we'll lose connectivity to your virtual network. For a similar reason, if you want to set up an NSG network security group, do not specify the default route. Last but not least, do not advertise the same prefix to us over Microsoft Peering and Internet, because that's actually the cause of asymmetrical routing. You don't want your forthcoming traffic on Internet and the return traffic to you over ExpressRoute, or vice versa. So with that, I'll hand over to Jared. Jared will talk about some new features.
Thanks, Charlie. So as a lot of us know today, we have a lot of different methods to be able to connect using ExpressRoute. The first major option is utilizing a co-location facility. So if you're in a facility today where you have a cage or a rack or multiple racks, being able to connect in utilizing an aggregation platform is going to be a really good method to do this today. In addition to that, you can utilize point-to-point Ethernet connections and be able to have that same capability, both handing off to us at layer 2. And then finally, you can utilize an IP VPN connection, MPLS, and use ExpressRoute as an extension of your MPLS network and have this as an additional branch. With ExpressRoute today, we have over 200 partners distributed across the world, and that allows for easy connectivity, very, very fast into our ecosystem, and to be able to extend your on-premises network into Azure. What I'm really excited to announce today, and what we've announced previously, is the ability to utilize ExpressRoute with connecting directly to us, utilizing ExpressRoute Direct. ExpressRoute Direct has a lot of exciting capabilities, and one of the things I'm most excited to say is that we are the fastest private connectivity in public cloud at 100 gigabits per second. What this offers you is the ability to say, I want to connect into the Microsoft ecosystem at one of the peering locations distributed across the world at dual 100 gig connectivity. Like Charlie mentioned, we want to be able to always ensure that you have availability in a given peering location, and because of that, we give 2 redundant connections in 2 different racks with 2 different routers. That's going to give you the burstability as well to say, if I do need to burst for a period of time that may not be sustained, I'm able to do that and be able to push traffic through at even greater than 100 gigs at time. What this is really, really good for is for the massive data ingestion scenarios, or MDI. That's going to be to push massive amounts of traffic into storage and Cosmos DB and Azure SQL. And when I'm looking to be able to start transitioning out of my current data center infrastructure and into a cloud provider, specifically Azure, this is going to be the best way of being able to get that data in there. I think we calculated about 1 petabyte per day I can push utilizing this connectivity option. With this, I have virtual circuits, and we've added 2 additional virtual circuit SKUs, 40 gig and 100 gig SKUs. So now I can allocate to a business unit 100 gig SKU and start pushing that amount of traffic today. What we've also done, and this is really exciting, and we'll demo this in a little bit, is the ability in a preview form today to say, I want to go 100 gigabits per second into my virtual network. Today, we utilize gateways, and we want to be able to optimize that data path further. And what this is going to allow us to do is through direct integration and very deep integration into our software-defined network, our physical routers are now able to talk into our software-defined layer and push traffic directly from the routers into the virtual network and into as many VMs as your physical connectivity at 100 gigs is going to allow for. This is going to be great for higher single TCP flows, packets per second, and connections per second. It's also going to be lower and more predictable end-to-end latency. The reason for that is that because we're deeply integrated into the software-defined network, we go from the physical router directly into that VM, bypassing any gateway in that path. The gateway may be deployed in a specific data center, and some of our largest data centers may be very spread out. In addition to that, it's going to provide improved reliability. ExpressRoute and ExpressRoute Direct are complementary options. For ExpressRoute today, you utilize a service provider ecosystem. Like Charlie said, and like I've said, we have 200 plus providers. And for most use cases, ExpressRoute is going to be the best option for that. It's very, very low barrier to entry, and it's going to be able to quickly integrate utilizing either point-to-point or into your MPLS. And I've seen in a lot of exciting cases, MPLS providers may be able to connect you up in just 30 minutes or less. Additionally, ExpressRoute Direct is going to be really good for some new use cases. Cloud service providers and multi-tenanted business units are now going to be able to buy out an ExpressRoute Direct port pair and then be able to allocate to different business units based on the use cases that you may have. A data center provider today that may be on premises and wants to start providing hybrid connectivity options, we're going to be able to now say that each customer of yours can have an allocated ExpressRoute virtual circuit and then allocate those out to each one of those individual customers with bandwidth allocations, et cetera. Now with ExpressRoute, like we've talked about, it gives you the connectivity into Azure. What we always talk about with ExpressRoute is it's not coming into one data center. It's not coming into just one region. It's coming into the Microsoft global network. And that's a really very important option and very important differentiator for us because when we add a new peering location, like Charlie said, we've announced quite a few in the last few weeks. With that, we're actually extending Microsoft's global network, our backbone, to each of those locations. So if you're peering in Washington, D.C. with us, on a standard circuit, you can get to us into anywhere within the geo, anywhere within North America. But with a flip of a flag, we switch to a premium circuit. I can now access all Microsoft public regions. That's huge. With ExpressRoute Global Reach, we've taken this a step further, and we've now said that if I have circuits in 2 or more places, I can utilize Microsoft's global network, that presence across the world in over 50 peering locations, to now connect my sites together utilizing those ExpressRoute circuits. This is going to be a really great option for on-demand capacity where perhaps your service provider may not be able to offer local connectivity, but Microsoft may have a presence there. And so working together with your WAN provider, we're going to be able to carry your traffic across our global network, and it's just a flip of a flag once again. We're really, really excited about this. Like I mentioned, with ExpressRoute today, we offer both a standard and premium option. Standard is going to keep us within the geo, and premium is going to allow us to access the global network. With just an add-on as well, we're going to be able to just enable global reach and start connectivity right away. This is going to be for private end-to-end access where I have a circuit perhaps in Los Angeles and an additional circuit in London. I can quickly set up those 2 circuits utilizing my service provider or utilizing ExpressRoute Direct, and now I just flip the flag on for global reach, and I set up the connections, a very, very quick setup process, and now I can get from my London office all the way back to LA, for example. Additionally, this is available in US government clouds, and we're really excited about this because this opens a lot of opportunities for our state and local government, as well as our federal customers in DoD space, because this is going to mean that within our different cloud that we offer today for the US government, they can also utilize the same service on day one. Now I'm going to jump to some demos. I'll just sign into. So what I'm showing here right now is a on-premises infrastructure, and ExpressRoute is great for extending my on-premises hybrid connectivity into the cloud. What we have here is we have physical servers pushing a lot of traffic right now. It's 4 physical servers, 10 virtual machines, all 10 gig NICs with SRIOV offloading this traffic off to the physical NICs. We've done a lot of optimizations on premises to try to mirror what an Azure VM can do. It's much harder than you think to actually push this amount of traffic from on-premises to the cloud, but I think we're going to try to do it. And so you'll see right now, this is going through a gateway path, and the gateway path has upper limits that we need to be able to watch out for. So I'm going to set the flag in the background, and this is going to be an option that's available later this year. And I'm flipping the flags in the background just because we're still actively working on this. Part of a normal operation would be that I would set up a connection and I would utilize the ExpressRoute Gateway bypass to be able to start pushing traffic. This is a one-time operation, and because of that, I'm running this in the background right now. Microsoft utilizes secure access workstations to ensure that I am securely accessing any customer environments. While that's running in the background, I'm going to switch over to show you some of the global reach capabilities. What this setup here right now is that I have an on-premises location in Seattle, and I have an on-premises location in Ashburn, Virginia, in our Washington, D.C. area. They're both utilizing service provider grade ExpressRoute circuits. And what I'm going to do is I'm going to add in a new employee. It's a very, very complex database I have here. It's one table, and I would expect that it's going to be very challenging here. So follow along. So I'm going to add in a new employee, and you'll see it's not committed at this point. In addition to being a very complex database, I am also going to commit the database. And what we're going to do in Ashburn is I'm going to just run a query here. What this is I've connected my VM that sits in Seattle and my Ashburn VM up to a domain controller that sits in an Azure VNet. And so these two are now talking over global reach. And we've just flipped the flag already in the background. And now what I'm going to be able to do is I'm going to see, is Anavi listed here? And she is. And so what that shows is that from Seattle to Ashburn, I've done an asynchronous copy, an asynchronous replication rather, and shown that the data is virtually instantly replicated across global reach. Obviously, a lot more complicated scenarios than this. Like I said, I'm not a database expert, but this was pretty exciting to see. I'll flip back over to Network Performance Monitor first, actually. And what I'm going to show here is the topology of what the global reach looks like. Network Performance Monitor is a really powerful tool to be able to show end-to-end latency, topology, etc. On the left side, you'll see the Seattle VM, and on the right side, you'll see the Ashburn VM. These are both in our on-premises labs on either side. This will show me end-to-end latency of about 75.5 milliseconds and the complete path in between. This is really great for troubleshooting as well as doing monitoring, reporting, etc. And so what you'll see is that we have successful connectivity, end-to-end linkage between the two of these. I'll flip back over to the 100 gig demo, and we'll hope that we flip back over, and you'll now see that I have 9.5 gigs pushing through every one of these. That means that I have pushed close to 100 gigs. So let's take a look at the monitoring and see what we're showing. And so we're just starting to grow this traffic now. You'll see throughout the morning I have been pushing about 98.66 gigs. This is a real lab environment, a real customer scenario where I've gone from Seattle to our US West 2 region and pushing that traffic actively directly to the VNet, bypassing the gateway, utilizing ExpressRoute Direct, all in one picture. And we'll start to see that we'll grow that traffic in just a little bit. And with that, I'll introduce Matthew Kuntz. He's the network architect at Johns Hopkins University, and he'll talk about the journey that he's utilized the journey that he's been on with us to utilize ExpressRoute Direct and all the various capabilities of ExpressRoute. Thank you.
Thanks, Sharon. Hi, everyone. I'm Matt Kuntz. I'm the network architect in the data center and enterprise networking team at Johns Hopkins University and Medicine. My team is responsible for all data center networking, along with enterprise connectivity between our major campuses and our enterprise connectivity to shared services such as the public cloud. So I want to start off with talking about our network and a little bit about us. We have approximately 10,000 networking devices across our entire enterprise. In the DC, Maryland, Virginia region, we have 5 hospitals, 2 data centers, and 1 university campus that are all linked with a fiber loop. And so we've got this for redundancy. It's a full circle. And along with this, my team is responsible for implementing a full DWDM infrastructure on top of this fiber. So it's all under our control. And we generally spin up 10 gig links, and we mux that over a 100 gig wave. Recently, we've started spinning up 200 gig links, and that's over a 200 gig wave. What this is truly buying us is we also run our own MPLS L3 VPN implementation, and we can spin up VRFs and security zones whenever and wherever we'd like. We have no additional cost other than the hardware for the DWDM infrastructure. And for us, we can provide our customers with either a very lenient security zone in the case of researchers, or a very strict security zone in the case of medical researchers. And those are 2 different things. So we started the Azure ExpressRoute story for us with 2 10 gig links through our Equinix location. We had success getting it started pretty quickly. But unfortunately, we ran into some, what we consider severe limitations. Again, I said we're used to being able to spin up VRFs whenever and wherever we want. And we found an immediate limitation that we could only do 1 security zone on an ExpressRoute circuit. And that's tied with 1 BGP private peering. So that was a big limitation. We didn't want to have to pay additional costs for ExpressRoute circuits to have more security zones brought out to the public cloud. In addition, as soon as we brought up then public peering and now Microsoft peering, we had limitations with bandwidth. As soon as we started pushing our backups to Azure, we hit 20 gigs peak, generally anywhere in the 18 to 20 gigs range throughout the day. This caused packet loss on private peering, and because of how sensitive medical devices are, they couldn't sustain connectivity, and it caused us a lot of issues. We actually had to back out our public peering or Microsoft peering until we could get a better solution in place. We ended up running it overnight when throughput was less. So that led us to a collaboration with the ExpressRoute team with Microsoft, and we beta tested the direct connectivity model. This led us to a couple of things. One, before doing this, we had a 30-second outage where our interface stayed up, but BGP and all traffic ceased. So BGP didn't go down until the timers expired. What came out of this is BFD. We've successfully tested about a 1 second failover or failure for some devices, and it wasn't even everything in the public cloud, from on-prem to the cloud. So for us, that's a huge win. The medical devices were happy, and we're happy because we don't have to be woken up at 3 a.m. with a network outage. In addition, the first iteration of the beta was Q&Q only. That led to problems for us because we couldn't find an affordable device that did full-blown MPLS, L3 VPN, 100 gig capability, and Q&Q. So my temporary solution to this was actually running 3 cables into the same switch, so 6 cables total, 3 on each side, mapping the C tags to a given S tag in Q&Q. And this was not desirable for us. It was unstandard, or substandard actually, because I would have had to wake up at 3 a.m. to troubleshoot this. I couldn't hand it off to a NOC. No one else really understood how it was implemented. So I needed to get this out of my network as quickly as possible. And that kind of leads me to the second iteration, where we are now. So with ExpressRoute Direct at 100 gig, we have a lot more flexibility. The first thing is we can bring up as many ExpressRoute circuits as we need, and we can have as many private peers as we need. This leads to a lot more security zones that we can bring out that may have really strict requirements. And our end goal to our customers is that we provide an on-prem and a cloud solution that they can't tell the difference. We don't want them to be, oh, that's in the cloud, we can see all this latency. Or, oh, that's in the cloud, I have to traverse another set of firewalls that I didn't before. Our goal is to make it seamless for everyone. And with ExpressRoute Direct, that's become a possibility now. In addition, our secondary data center is in the Northern Virginia area, and we have 2 to 3 milliseconds over our fiber infrastructure for any traffic from our main enterprise to that DR data center. In comparison, with Azure, we have 4 to 5 milliseconds to US East. For us, that's a huge victory. A customer can't tell the difference in our applications between 2 to 3 milliseconds and 4 to 5 milliseconds. So it has become just as viable of an option for a data center. And what I'm most excited about is that I got rid of my octa cables on my switches, and we have a standard .1Q implementation. So all we do is bring up another ExpressRoute circuit. It's a different set of VLANs. We've got 2 100 gig links. We can oversubscribe or not as we choose. And it's a standard implementation. Everyone on my team understands .1Q and BGP. Not everyone was able to understand Q&Q at the same pace because it's such an odd configuration for us. It's not part of our enterprise standard. And I think another exciting thing that's coming for us with ExpressRoute is we have a 6th hospital in St. Petersburg, Florida. We have fiber connected to them now at 1 gig per side. We have redundancy. We want to leverage ExpressRoute to be a WAN, or Azure and ExpressRoute to be a WAN provider for us. We can bring them into a local POP in Florida at 10 gigs or 1 gigs, whatever we need, and then bring them up to our head end at 100 gig direct connectivity to Azure. And all this is building a reliable, robust infrastructure that we can provide the best patient care and research that we can to our customers and hopefully the greater community. Thank you.
Thank you, Matt. So Jared talked about 100 gig direct and global reach. Up to my knowledge, we are the first public cloud service provider offering this capability. But we have more to share. First, monitoring. Monitoring is fundamental and it's critical. We've added more capabilities. So now you can actually get the bandwidth utilization for your Microsoft peering and Azure private peering. Now, many of you also have many VNets connected to a single ExpressRoute circuit. You can also get bandwidth utilization per VNet connections. You can also define alert on traffic level. So you can choose to send an email to yourself or text yourself if a throughput goes above a certain threshold or drops below a certain threshold. You can also see your activities, operation activities in activity log. For example, if you change your circuit, upgrade your gateway, these operations will appear in activity log. You can also define alert for this activity. So you can find out who does what at what time. Network performance monitor, actually, Jared just showed it to you, is an end-to-end connectivity monitoring tool. You can define a service, you can define any endpoint, whether it's on private peering or on Microsoft peering, and you can probe this endpoint. You can use a network protocol to, like ICMP, or you can also probe this endpoint, use HTTP. We added the support of multiple subscription because many of you have multiple Azure subscriptions. You may create ExpressRoute circuits using different subscriptions. So now you can see all these activities from, through a single lane of glass. So we recommend you to have 2 or more ExpressRoute circuits for redundancy. So this picture may, this picture may look familiar to you because that's actually from last year. So at the last year, we talked about how you can use connection weight, how you can use BGP to inference routing. So you may want to set one ExpressRoute to be active and the other to be passive. We got many questions. People told us, we followed your guidance, we have a design, we implement active and passive, but how do I validate it? It turns out it's actually not very straightforward because many users don't have access to their physical routers. So what we do is we create a new API. So with this new API, with a few PowerShell commands, you can turn off your peering on your ExpressRoute. Once you shut down ExpressRoute peering, traffic will be forced to the other circuit. And you can use NPM to monitor the connectivity. Of course, if you have to implement this correctly. Now, Matt also talked about BFD, bidirectional forwarding detection. So I want to give a little bit more details about it. If we are familiar with BGP, BGP has a built-in timeout mechanism. But the problem with BGP is it will take up to 3 minutes to timeout. Now, if your application is super sensitive to outage, like a gaming, your application will fail. For example, if you play a game, if a game server detects a failure, it basically will shut down your session. It's a game over for you. You have to start all over again. So with the BFD, you can fail over from your primary connection to your secondary connection, or from one circuit to another circuit in a few seconds. And most applications, because most applications are TCP-based, most applications will survive because of the retransmission mechanism. Now, a few things you need to know. When you set up a BFD, you have to make sure the network between your router and the Microsoft is layer 2, because our design needs to have a layer 2 network between us. We don't support a multi-hop BGP from technical perspective. When you enable, you can also, if you have a new circuit, let's say your circuit actually is created after August 1st, BFD is actually enabled by default on Microsoft side, but you do have to enable it on your router. Now, what if your circuit is created before that? Now, remember I talked about an API. You can use the same API to reset your peering, the peering of your circuit. Once the circuit turned up again, we'll put the BFD configuration on our router, so you can set up a BFD. Of course, you should schedule work maintenance when you do this. Azure Virtual WAN is a new service. We have a session to talk about this service tomorrow. But simply put, Azure Virtual WAN is designed for companies with a massive number of branch offices. So we are talking about up to 1,000 side-to-side VPN tunnels, 10,000 point-to-side tunnels. We also worked with our SD-WAN partners, VPN partners, to simplify management. The goal is with a single click, you can set up a connection between your branch office and Azure Virtual WAN. Azure Virtual WAN supports VPN and ExpressRoute. VPN is GA. ExpressRoute is a new capability we just added. It's in public preview. One thing I want to call out is to plug in ExpressRoute, to support ExpressRoute in Virtual WAN, your ExpressRoute circuit must be created from a location where we support global reach. And one thing we're really excited to share with you is this routing capability between ExpressRoute and the VPN. So many of you asked us for this capability, and you have it now. So another thing is zone redundant gateway for high availability. Zone redundant gateway supports Azure availability zones. Azure AZ, each AZ is a unique Azure, a number of Azure data centers in a region. So each AZ is physically and logically separated, isolated from each other. Now, when you create a virtual WAN, virtual network, you need to create a virtual a VNet gateway. Our VNet gateway is a software implementation. It has a number of VMs. With a zone redundant gateway, we guarantee that these VMs will be created in different AZs. So if one physical data center or one AZ has outage, you still have a connectivity to your VNet. Now, it's a GA service, so it should be no surprise that this is new SKU, new gateway has a feature and a performance parity with our existing gateway, standard, high-perf, and ultra-perf. So we made other improvements. One is, this picture is also from last year. Many of you want to have a VPN and ExpressRoute in the same VNet for redundancy, for hub and spoke topology. Now, in the past, we require you to set up ExpressRoute before VPN. It's actually not practical. We learned because many of you set up a VPN first before move on to ExpressRoute. We made an improvement. We've removed this restriction. So now you can set up or you can create or delete VPN or ExpressRoute gateways in any order. We also added a new BGP community on Microsoft peering, Azure Active Directory. Azure AD just re-IP'd its service. So basically, it consolidated its public IPs into 2/18 blocks. So you can now choose to enable Azure AD on ExpressRoute or choose to access Azure AD over the public internet. We also, last but not least, we also made an improvement on ultra-perf gateway. It used to be capped by 9 gig. We bumped up the performance because we just like rounded the number. To summarize this session, we give you a lot of information. We are continuing to grow ExpressRoute ecosystems, partners, and the locations. We shared with you the key lessons we learned. We want to make it very clear, while we're still making investments in new features, we are also making investment in existing capabilities like monitoring and gateways. So we still have many minutes left. If you have any questions, please come over.
Come to the mic.
Okay, you can also come to the mic. We'd be happy to answer your questions.
Thank you.
Thank you for coming.
Go ahead.
On the 100 gig pass, does that mean if we're setting up, is that like a direct, we go to some provider like Level 3 or somebody, grab a direct circuit between us and you, and then potentially do that twice at each location?
Yeah, so you would, Microsoft is not looking to provide last mile connectivity, right, but we will you'll work with your last mile provider, meet us at one of our various 50 plus peering locations around the world, and then do a physical cross connection. We'll issue a letter of authorization.
Okay, now are those peering places a subset of the existing, Cyrus One and Equinix is a subset of those then?
Yep, it's a subset of them today. We're looking to expand to all of the peering locations in time.
Okay. Thank you.
Thank you.
I have a question.
Yes.
Go for it.
So you're stating that you're doing BFD to the peering, is that BFD to the peering partners, right?
For private peering, yes.
So if I'm a normal customer and I'm choosing, let's say, Verizon or Zayo or whatnot, does that imply that all the partners that you have partnership with right now have?
Yeah, this is something we need to communicate with our our partners. You can also provide feedback to the service provider. We'd like
So
to
it's not
enable
something
this.
implemented today across all the partners?
Okay,
You'll need to work with each provider to be able to understand if they have BFD support today. We have worked with some of the providers already that are up and running, and they're utilizing BFD successfully.
Thank you.
Yeah.
Thanks. Go ahead.
Hi. You said it's possible now to add the ExpressRoute gateway also to an existing VPN gateway, right? Or via VNet, where it is also in a VPN gateway. All SKU or only on the new SKU?
So is that for availability zones, are you asking?
No, is adding ExpressRoute gateway to an existing VNet.
Yes, you can do
also
that.
a VPN gateway.
Yes.
Yes, you can do that.
Yep.
In all kind of VPN gateway, or there are specific one?
The standard, the high perf, and there's a VPN gateway 1, 2, 3.
Okay.
You can do that.
Okay, perfect.
Yeah.
Thank you.
Use a PowerShell. I think one thing I didn't mention is use a PowerShell. The portal support will come later.
Okay, now it's PowerShell. Okay.
Yeah.
Yep. Go ahead.
What are some of the legacy VPN gateways that you currently have, like high performance and standard?
Yes.
Moving to the new gateway SKUs yet? What does the performance look like between having Azure ExpressRoute and the compatibility of using some of those legacy systems?
So each VPN gateway has its performance. So that's when you fail over for ExpressRoute, you need to look at the VPN gateway's performance, so you can make sure when you fail over, you don't have a performance degradation.
Right, so would that mean that we would have to try to upgrade our existing gateways to the new gateway SKU, or be able to?
So I think the best way to look at it is we actually publish this performance on our web page. So probably look at our web page for the performance.
No, I understand the performance part. What my question actually is there any compatibility issues that we'll face if we continue to have the high performance gateway with some of the new stuff that's coming out with that?
There's no compatibility issues.
Okay.
Yeah.
Thanks. Go ahead.
Just to be clear, Microsoft peering is now available over ExpressRoute.
Yes.
In the past, that wasn't the case. Is that correct?
Yeah, so when we announced merged peering to be able to take everything that we had in public peering and add the capabilities into Microsoft peering, we removed the restriction. There are some services within Microsoft peering and the route filter that you would need to get authorized to be able to utilize, but all of the Azure public regions, Azure East US, for example, I can enable today using Microsoft peering and have no issues.
Okay, and your recommendation is to do URL filtering and not IP filtering?
Yeah, URL filtering is going to be the most scalable.
All right, thank you.
Thank you. Go ahead.
I don't have any production Azure workloads right now, but I'm mostly interested in optimizing performance to the Microsoft Office 365 cloud, or Teams performance, for example.
Yep.
Does this help me with that?
Yeah, so I'd recommend reaching out to the Office 365 team. They have a booth here as well, and they can talk about connectivity and how to best optimize it. Office 365 is designed as an internet-first service, and because of that, internet is going to be the most optimal way of accessing it, utilizing internet breakout at local branches and headquarter offices.
Okay, so this is not necessarily going to give me a more express route to the internet cloud.
That's correct. Thank you.
Hey, so my question is on the ExpressRoute Global Reach. So
Yes.
when is it going to be GA, and when it's GA, what's going to be the impact for the existing ExpressRoute connections that we have? So would there be any downtime in order to enable that, or?
Yeah, we hope to GA in a few months because we want to have more customers to play with it, to get have some mileage for us to flush all the bugs before we announce GA. Is there any specific country in your mind?
No, it's US. But
Okay.
my question is related to when it's GA, what's going to be the impact for the existing ExpressRoute connections? I mean, when we enable that, or if I need to enable that, is there any downtime or anything?
So there's no downtime.
No downtime.
The goal is to, when you enable this, you can just enable on your existing ExpressRoute circuits.
Okay, perfect. Thank you.
Go ahead, sir.
So I've had problems with ExpressRoute and Q&Q with my provider.
Sorry about that.
It is painful. And particularly when you have a network team that you have to work with in there. Are there other ways to handle the primary and secondary circuit without having to implement Q&Q?
Yeah, so I would definitely recommend working with your service provider, and if that hasn't worked to date, please come up after and we can definitely discuss. What service providers are doing is, under the covers, we allocate a specific S-tag as part of the Q&Q process, and that's what the service provider is using to be able to implement segregation across the physical infrastructure.
I understand that, okay. But the problem that was discussed earlier with Q&Q is very similar even with a regular standard ExpressRoute circuit. It is a non-standard implementation. It's flexible because your provider then gives you the full ability to bring up and tear down your express routes and move them around.
Yep.
But the other side of that coin is it needs to be discussed up front. And I know you say that's a provider issue, but it needs to be, more importantly, discussed a little better in your documentation also. I went back and finally found a little blurb on it. I would recommend that maybe you can make it a little bit.
Sure, and if you want to stop by after, I'd love to hear some additional feedback.
Q&Q is not a requirement for end users if you don't directly connect to us, just have to make sure.
Go ahead.
So now, as is with the ExpressRoute Direct, higher speeds available, let's say 40 gig, 100 gig. What does it mean for the speed to individual VNet, and is the speed, especially when it comes to the gateways, is the speed limited to 10 gig per VNet?
Yeah, that's a good question. So a few key aspects there. 40 gig and 100 gig are virtual circuit SKUs. The actual physical connection coming in, utilizing ExpressRoute Direct, is at 100 gigabits per second. Coming into the VNet, I had demoed the ability to be able to bypass the gateway for some specific use cases. We'll look to preview that hopefully by the end of the year with customers and perhaps take in some private preview customers. We announced as well today that we've bumped up our gateway just slightly to get to a round number, like Charlie said, at 10 gigs per second. So a single VNet can take in 10 gigs today.
I'm in the process of installing an ExpressRoute over the next couple of months. So as far as some of the mechanics are concerned of BGP-AS, you were stating that in one of your slides that I need to have a public assigned.
You need a public ASN in order to influence routing.
For Microsoft peering.
For Microsoft peering.
Do customers provide,
usually
do the peering ISPs provide ASNs? Because I can't go to Aaron and just ask for an ASN.
We also support not just the 2-byte ASN, you can also get a 4-byte ASN, which is much easier to get than 2-byte because it's very limited. Because there's a public 4-byte ASN. Once you get that, you can use that for your BGP peering. You can use that to influence routing.
So as a customer, I have to go to Aaron and get an ASN for them just to have influence routing between express routes?
Yeah, so depending on the service provider you're using, if you're utilizing a layer 3 service provider, in most cases they're going to help to influence the routing as well, and you mentioned a few that came to mind to me. If that's the case, a layer 3 provider is actually who's peering with us from a BGP perspective and not you directly. If you're utilizing a layer 2 provider in a colo or point-to-point scenario, it would be you peering with us directly.
I would like to do some path prepends in order to influence how I push routes out of my data centers.
That's correct. So you'd want to use a public ASN, and like Charlie said, you'd request that through Aaron. There shouldn't be any issues for...
Sucks, but thank you very much.
Yep, sorry about that.
Charlie, I was working on failover setup for ExpressRoute and VPN. Coexist in a single VNet. I found that we cannot attach static public IP to VPN gateway. Why is that? That's very...
Yeah,
it's a limitation for our implementation, but we do have a plan to add this support when we actually change our implementation.
Oh, okay.
Yeah.
That's good to know.
Thanks. Any other questions? If not, we're out of time.
Around, feel free to come over. Happy to talk to you.
Yeah. Thank you.